This is section 5.6, Properties of Exponents. In this video, we're going to review the properties of exponents. In this table, you can see the properties. There's the product rule, the power rule, the quotient rule, the zero exponent rule, and the negative exponent rule. Let's take a closer look at each one of these. Let's start with the product rule. When we use the product rule, we add exponents when multiplying with the same base. Use this sum as the exponent of the common base. Let's look at the examples provided. The first example we have is 2 to the third power times 2 to the fourth power. This equals 2 to the seventh power because we're going to add the exponents. We have 3 and 4 equals 7, 2 to the 7th. And of course, we're going to keep the common base. You notice that the base here is a 2, and here it's a 2. So we end up with 2 to the 7th power as our answer. Let's look at our second example. We have x squared times x to the 9th. Notice once again we have the common base of x. We're multiplying, so we're going to add the exponents of 2 and 9, and we're going to get a finished answer of x to the 11th power. And finally, we have an example m to the 5th times m to the negative 2nd. We have the like base once again, so we do 5 plus negative 2, and we get a final answer of m to the 3rd power. All right, next we're going to look at the power rule. It says that we multiply exponents when an exponential expression is raised to a power. Place the product of the exponents on the base and remove the parentheses. So let's look at our examples. We start with 2 to the 3rd raised to the 2nd power. So what we have is we have an exponential expression, 2 to the 3rd, being raised to the power of 2. So the power rule tells us that we are going to multiply the exponents. Well, in this case, our exponents are 3 and 2. Multiply those together and we get 6. Of course, we keep the base that we started with, and we end up with a final answer of 2 to the 6th power. Our second example, x squared raised to the 4th power. The power rule tells us to multiply the exponents, so we end up with x to the 8th as our answer. And finally, m to the negative 5th power raised to the 2nd power. The power rule says to multiply the exponents, so negative 5 times 2 is negative 10. We end up with m to the negative 10th power as our answer. The next rule is the quotient rule, and it tells us to subtract exponents when dividing with the same base. Use this difference as the exponent of the common base. So let's look at our examples. We start with 2 to the 5th divided by 2 to the 3rd. Since we are dividing, we use the quotient rule. Remember, quotient is the answer you get when you divide. So, in this case, we're going to subtract our exponents. 5 minus 3 is 2. So our final answer is 2 squared. Next example, x to the 7th divided by x to the negative 2. Since we're dividing, we use the quotient rule. And in this case, we're going to subtract our exponents. 7 minus negative 2. Now remember, 7 minus negative 2 is the same thing as 7 plus 2. That's why x to the 9th is our answer. That brings us to the zero exponent rule. Any number or variable raised to a power of 0 equals 1. 3 to the 0 power equals 1. X to the 0 power equals 1. 2m to the 5th. We have an exponential expression here. being raised to the 0 power, it equals 1. And finally, we have the negative exponent rule. To make a negative exponent positive, move the term from the numerator to the denominator or vice versa. All right, so let's look at our example here. 2 to the negative 2. Well, remember that 2 to the negative 2 is written as 2 to the negative 2 over 1. So if we want to make our exponent of negative 2 positive, we're going to move 2 to the negative 2 to the denominator, where it will become 1 over 2 squared. Of course, 2 squared is 4, so our final simplified answer is 1/4. Our next example, 1 over x to the negative 5th. We recognize the negative 5 as the exponent. We don't want negative exponents, so we need to make it positive. We do this by flipping the x to the negative 5th from the denominator up to the numerator, and it becomes x to the 5th power. All right, now that we've gone through the properties of exponents, let's put them to use in simplifying some of these algebra expressions. Let's start on the left here. 9 to the 0 power over y to the negative 5th. So there's no single process to go through in any of these problems. It really depends on which properties you see first. For example, in this problem, the first thing that jumps out of me is that 9 to the 0 power would use the 0 exponent rule. Anything raised to the 0 power equals 1. So I can rewrite this as 1 over y to the negative 5th. Now as I do that, the next thing I recognize is we have a negative exponent here, y to the negative 5th. And I know from the negative exponent rule that I don't want negative exponents, so I'm going to flip this up to the numerator. In a sense, I'm taking the reciprocal, and it will become y to the positive 5th over 1, but of course we don't have to write over 1. And so y to the 5th is my final answer. Let's look at our second example. 3x to the negative 6 over 9y to the negative 2. All right, so the first thing that I recognize is I have some negative exponents. Now, this is very important. Pay close attention. This negative 6 exponent only applies to the x. The 3 has its own exponent, and it's actually 3 to the 1st power. The negative 2 exponent in the denominator only applies to the y. The 9 actually has its own exponent, and it is also a 1. So, in order to remove, or not remove, but to change our negative exponents to positive, we're going to flip them, but we're going to leave the 3 and the 9 alone because they already have positive exponents of 1. So the x to the negative 6th will flip down to the bottom and become x to the positive 6th. Y to the negative 2 will flip from the bottom to the top and become y squared. Now the only thing left to do is to simplify this fraction right here. 3/9. 3/9 reduces to 1/3. So really we have 1y squared over 3x to the 6th. And this is my simplified answer. All right, third example. B to the 3rd times c to the 0 power times b to the negative 1 times c to the 5th. All right, so which property jumps out at you first? Well, I know for me, it's the 0 exponent rule right there. C to the 0 power will equal 1. So now I have b to the 3rd times 1, which is just b to the 3rd, times b to the negative 1 times c to the 5th. Okay, now the parentheses in this problem is representing multiplication. It's really not doing a whole lot. In fact, we could get rid of it if we wanted to, and just put in its place another multiplication symbol. Okay? Now, the next step, you have some options. You might be saying to yourself, there's a negative exponent, I want to make that positive. And that would be okay. But you also need to recognize that this is the product rule right here. I am multiplying with the same base, in this case, b. And when I apply the product rule, I add the exponents. So in this case, b to the third times b to the negative first would end up being b squared, because 3 plus negative 1 is 2. Now, what I've done is I've avoided having to use the negative exponent rule. Because by using the product rule and adding 3 plus negative 1, that negative exponent has gone away anyways. Now, I still have times c to the fifth, but hopefully you're remembering that we only use the product rule when we have the same base. And in this case, we have base b and base c. They obviously are not the same, so this is our simplified answer. All right, here are some more examples. Let's keep going. This is one of those algebra skills that you have to practice, practice, practice in order to get it. All right, so we have a to the third times b squared, all raised to the negative 2 power. All right, so since I am raising an exponential expression to a power, I can use the power rule. And the power rule tells me to multiply exponents. So I'm going to do that. A to the third raised to the negative 2. I need to multiply 3 times negative 2 and get a to the negative 6th. Then I have b squared raised to the negative 2, and that will give me b to the negative 4th. Now I recognize negative exponents, so you apply the negative exponent rule, flip these to the denominator, right? Think of this as being over 1, so I can flip those to the denominator, so I end up with 1 over a to the 6th times b to the 4th. I cannot use the product rule because in the denominator I do not have like bases, so that is my simplified answer. All right, second example on this page, 56a to the negative 4th, b to the 0, over 8a to the negative 8th. All right, first thing that I recognize is b to the 0 equals 1. So I can rewrite this as 56a to the negative 4th over 8a to the negative 8th. All right, next thing that I recognize is I am dividing with the same base right here. A to the negative 4th divided by a to the negative 8th. So I can use the quotient rule. And the quotient rule tells me to subtract the exponents. So in this case, negative 4 minus negative 8, this becomes negative 4 plus 8, which ends up equaling positive 4. So what I end up with is 56a to the 4th over 8. Now, 56 divided by 8, that can be simplified also. 56 divided by 8 is 7. So my final simplified answer here is 7a to the 4th. Next example, 2c to the negative 2 times 4d to the 0 times 5c raised to the negative 5th power. All right, things are getting more complicated, so make sure that you're paying close attention. First thing I recognize is d to the 0 equals 1. So I have 2c to the negative 2 times 4 times 1 is 4, times 5c all raised to the negative 5th. Okay. Next thing that I see some negative exponents, but I'm not going to do anything with those yet. What I'm going to do next is I'm going to use the power rule over here with our exponent of negative 5, because I have the exponential expression 5c being raised to an exponent. Now you have to be careful here. 5 has its exponent of 1 and c has its exponent of 1. So I need to multiply each of those by negative 5. So what happens, this is going to stay the same for now. This is going to stay the same for now. And now I'm going to end up with 5 raised to the negative 5th times c raised to the negative 5th. All right, I used the power rule there where I multiply the exponents. Okay, now I have a lot of negative exponents going on, so let's get rid of those. We get rid of those by flipping them to the denominator. So all of a sudden, 2c to the negative 2 becomes 2 over c squared times 4, which is 4 over 1. It might be helpful to write it like that. Times, okay, 5 to the negative 5th would flip to the bottom, c to the negative 5th would flip to the bottom, so we have a 1 on top, 5 to the positive 5th, c to the positive 5th. Alright, so everything is being multiplied, so let's multiply our fractions. Multiply the numerator straight across. 2 times 4 times 1, that's 8. On the bottom we have c squared times 1 times 5 to the 5th, c to the 5th. Well, hopefully you are seeing the product rule, because we have c squared times c to the 5th. The product rule tells us that when we multiply with like bases, we add the exponents. So that comes out to be c to the 7th. And 5 to the 5th, we can figure out what 5 to the 5th is. You might need to use a calculator here. 5 to the 5th is actually 3,125. So you would want to ask yourself, can 8 over 3,125 be reduced? And in this case, it cannot. So this is our simplified answer, 8 over 3,125 c to the 7th power. All right, one final example. And it might be the most complicated, so pay attention here. First property that I see is the zero exponent property right there. J to the 0 is going to equal 1. So I'm going to rewrite this as k to the negative 3 raised to the negative 3 over j to the negative 3 raised to the 3rd. Now, I have a lot of negative exponents there, but I'm not going to use the negative exponent rule yet. I'm going to use the power rule first, because both in the numerator and the denominator, I have an exponential expression being raised to a power. So, in the numerator, k to the negative 3rd raised to the negative 3rd. The power rule tells me to multiply the exponents. Negative 3 times negative 3 is positive 9. And that's nice because the negative exponents have gone away. In the denominator, I have j to the negative 3rd raised to the 3rd. That'll give me j to the negative 9th. Now I still do have one negative exponent, and I can get rid of it by moving it from the denominator into the numerator. So I will end up with j to the 9th, k to the 9th. I cannot use the product rule because these are not like bases. And it should be noted that whenever we write an algebraic expression, we put the variables in alphabetical order. And in the alphabet, j comes before k. So this is my simplified answer, j to the 9th, k to the 9th. All right, we covered a lot of examples and a lot of information with the properties of exponents here. This is a quick review. Go back. This is in your book, so you can refer to it in your book as well. Remember, we're in section 5.6.